My project is on AC to DC converter. So why do we first of all need to do this? So the power supply which we get at our homes is generally AC, but most of the appliances at our homes they work on DC supply. So we need to convert AC to DC in some way, and the process by which we do this is called rectification. So an AC supply is which in which current keeps changes its direction after a certain interval of time, and in DC supply the current flows constantly in one direction. So let's now see how this can be done. So rectifier. Rectifier is a device that converts AC to DC. There are many types of rectifier which we can use like half wave, full wave and bridge rectifiers, and the diodes play a very crucial role in the making of a rectifier. So let's begin with half wave rectifier. So a half wave rectifier consists of a single diode connected in series with the load. In half wave rectification, a single phase AC supply is fed to a half wave rectifier circuit. The diode passes only the positive half cycle of the supply and blocks the negative half cycle. So as we can see, firstly in the left figure, when we supply a high AC voltage to the primary side of a step down transformer, then in the secondary coil we will get a low voltage. So and the secondary coil also has a diode in it. So the diode is forward biased during the positive half cycle of the AC voltage and reverse biased during the negative half cycle. So the final output voltage waveform which we get is like this. Uh, the upper waveform is for AC and the lower for DC. So we can see that only the positive half cycle of the AC supply has been converted into DC, and the efficiency of a half wave rectifier is 40.6%. Now let's see the working of a full wave rectifier. So a full wave rectifier is capable of converting both the polarities of the input AC into DC. A full wave rectifier consists of two diodes which are connected in such a way that one diode will be forward biased and the other one will be reverse biased for a particular half cycle of the AC supply. So in full wave rectifiers, the output voltage can be obtained during both positive and negative half cycles of the AC supply. So firstly, suppose we have a very high input AC. So this primary coil steps down that supply and a relatively lower supply is given to the secondary coil. Now the secondary coil contains two diodes D1 and D2, and for a particular half cycle, uh, one diode will be forward biased and the other one will be reverse biased. So suppose during the positive half cycle of the alternating current, the top half of the secondary winding becomes positive while the second one of the secondary winding becomes negative. So during the positive half cycle, diode D1 will be forward biased as it is in the top part of the secondary winding, while D2 will be reverse biased as it is in the bottom part of the secondary winding, and vice versa. So we will see that for both the half cycles, which is the positive as well as negative, we will get it converted into DC. So this is the waveform for a full wave rectifier. So the first one is the AC supply, and for the positive half cycle of the AC supply, diode D1 is forward biased, so it gives us this. And since diode D2 was reverse biased, so it's at constant 0. And then for the negative part of the AC supply, D1 is at 0 while D2 gives us the output as DC. And then finally, for by combining both the outputs of D1 and D2, we get this output, and we can see that full the AC supply has been converted into DC. So this is how a full wave rectifier works, and the efficiency of it is 81.2%. Now let's see the working of a bridge wave rectifier. So a bridge wave rectifier consists of four diodes connected to form a closed loop called a bridge across the load. In a full wave bridge rectifier, two diodes will be conducting for each half cycle, and the rest two diodes will be reverse biased. So now suppose we apply a AC input across this. So during the positive half cycle, when the terminal A is positive and terminal B is negative, then we will have that diodes D1 and D2 they will be forward biased, while D2 and D4 they will be reverse biased. And during the negative half cycle, A will be at negative terminal, B will be at positive terminal. So D2 and D4 they will be forward biased, while D1 and D3 will be reverse biased. So in this way, the bridge wave rectifier will allow electric current during both the positive as well as the negative half cycles of the input AC supply, and thus we will be able to get the DC output as we can see here in the waveform. So this is how bridge rectifier works, and its efficiency is also 81.2 percentage. So this was my presentation on rectifiers, and using all any of the three rectifiers we can convert AC to DC. So we also use rectifier for modulation and demodulation purposes. Thank you. Hope you liked my presentation.